So in today's lesson, we're looking at the perfect square rule for factorising an algebraic expression from polynomial form down to factorised form. So remember that a square number is any number multiplied by itself. So 3 squared is the same as 9, or 3 times 3 also equals 9. So we're going to look at 15 squared, so the perfect square rule. So we know that 10 plus 5, 10 plus 5, using our area model, we have 10 times 10 is 100, 5 times 5 is 25. We also have 10 times 5, which is 50, and 10 times 5, which is 50. So here, out of 10 plus 5 times 10 plus 5, or 15 squared, we have 10 squared plus 5 squared, but we also have 10 times 5 plus 10 times 5. So here we actually have two lots of 10 times 5. So in this, we actually have 100 plus 2 lots of 50 plus 25. So 100 plus 25 equals 225. So 15 squared equals 225. But the important thing we want to actually look at are these two 50s. So we have 10 squared, which is 100, and 5 squared, which is 25, but it's these two numbers that will actually help us later on. But let's try another one and see if we get the same sort of pattern. So let's go with 12 squared. So we have 10 plus 2, 10 plus 2, so that's 12 times 12, 10 squared, or 100. We have 2 times 2, which is 4. 2 squared, or 4. And we have 10 times 2, which is 20. And we have another 10 times 2, which is 20. So we again have 10 squared plus 2 lots of 10 times 2 plus 2 squared. So 100 plus 20 times 2, which is 40, plus 2 squared, which is 4, 144. Again, we have this pattern of these two multiples factoring in the same sort of way. We'll do one more, but this time we're actually going to make it a subtraction instead of an addition. So we actually want to know 8 squared. So we've got 10 minus 2 and 10 minus 2. We have 10 squared. We have negative 2 times negative 2, which is actually a positive 2 squared. And we have 10 times negative 2, which is negative 20. And again, we have another 10 times negative 2, which is negative 20. We're seeing the same pattern again. 10 squared plus 2, 10 times negative 2 plus 4. Sorry, that should be 2 squared. So we have 100. So 10 times negative 2, which is negative 20, times 2, which is negative 40, minus 40 plus 4. So we have 60 plus 4, which is 64, which is the same as 8 squared. So again, we have this same pattern here. We've got a negative there now, but it's actually the same pattern. Let's see what happens if we start using some variables within this rule. So let's say we have x plus 2 squared. So we have two numbers that will actually be squared out. This is written as x plus 2, x plus 2. And that's the same thing. So we have x and 2, x and 2. So we have x squared, 2x, 2x, and 4. And this 4 is actually 2 squared. So we have x squared plus 2x plus 2x plus 2 squared. And when we simplify this, x squared plus 4x plus 2 squared, or 4. Both are correct, same thing. And we can try it if it's the other way around. X minus 2 squared. So we have x minus 2, x minus 2. So we have x minus 2, x minus 2. X squared minus 2x minus 2x. And negative 2 times negative 2 is a positive 4. If we simplify this, we have x squared minus 4x plus 4, which is the same as 2 squared. So we're starting to see the same sort of pattern here. But remember, what we want to do, we don't want to look at expanding these. We want to look at factorising these. So we're going from this form here. We actually want to go back to that form. There is a rule to do this. We've explained the expanding. Let's look at the factorising. So if we have x squared plus 6x plus 9. So we have an x squared there. 9 is 3 squared. So that we know that we have these two are both squared. So we have to have an x there. We have to have a 3 there, an x there, and a 3 there. Because our middle, our b term is what it's called, is positive, both of these are actually positive as well. Let's see if this works. We know that x times x is x squared. X times 3 is 3x. 3 times x is also 3x. And 3 times 3 is 3 squared, which is also 9. So let's see if that simplifies down to be what we want it to be. So x squared plus 3x plus 3x is 6x. And 3 times 3 is 9, so plus 9. So that does work. So we know that x plus 3 are the factors of x squared plus 6x plus 9. And we can also write this as x plus 3 squared. That's the same thing. Let's try it if they're both negatives as well. So we want x squared minus 8x plus 16. So we have a squared term there, and we also have a squared term there. So x squared, square root of 16 is 4. So that's 16, we have a 4 there and a 4 there. This term here is negative, so we have to have two negatives. Let's see if this works. So x times negative 4 is negative 4x. Negative 4 times x is negative 4x. So x squared minus 4x minus 4x, they're both negative, so it goes more in the negative direction. It becomes negative 8x plus 16. So that works and gets us back to where we were to begin with. So we now have x negative 4, x minus 4 is our factored form of x squared minus 8x plus 16. So let's take the numbers out and let's just use some variables to look at and explain this rule a little bit more. So we're going to go a plus b all squared. Let's write that a little bit neater. A plus b all squared, which is a plus b, a plus b, a plus b, a plus b. So we have a squared and b squared. And here we have a b, and down here we have a b also. So we have a squared plus 2ab plus b squared. Well, if we see that every single time, if we see two numbers that are both squared, and the middle number, so we have our a term squared, our b term squared, and our middle term, or our b term, is showing us 2 times the other two numbers. We actually have a rule here. So a squared is the same as a squared plus 2ab plus b squared. So there's one of our rules. Our other rule we want to look at is a minus b squared. So a minus b, a minus b. So we have a squared. A negative term multiplied with a negative term becomes positive, b squared. So negative a b, negative a b. And we actually have, again, a squared minus 2ab minus, plus b squared. So if our last term is always positive and a square, then we can actually use our rule still. So I hope this helps you understand how the perfect square rule actually works from an expanding to a factorising form and also back again. So you've got to be able to do both to double check your answers. So continue with our notes and look forward to seeing you in class.